Good afternoon, everyone. How are you all? Very good. So today lesson we'll understand one topic, that is momentum and change in momentum. Okay. We'll understand what is the definition of momentum, and based on change in momentum, we'll try to solve some questions. Please come in. Okay. So all of you, first write heading momentum and change in momentum topic. Write heading, right? Momentum and change in momentum. So first to define what is momentum. What is momentum? Momentum is a physical quantity which is a vector quantity basically. Okay. It is defined as what? Now write down here. Momentum is defined as the product of mass and velocity. Mass is scalar, velocity is vector. So scalar into vector, it will give you a vector quantity. So momentum is defined as the product of mass and velocity. So first one, write definition. And if you mathematically want to represent, or formula you want to write, mathematically what? Write momentum equal to mass into velocity, where P is basically momentum, M is mass, and V is velocity. So this is the basic idea already you have. Basic idea you have. Okay. But little will go further and we'll try to understand deep inside that momentum and change in momentum. So some normal idea what you know about momentum. Now it is a vector quantity. Momentum is a vector quantity. Momentum is a vector quantity. And if you want to write SI unit, the SI unit of momentum, SI unit of momentum is kg meter second inverse, or you can write Newton into second. Okay. And remember, if it is a vector quantity, its direction is always in the direction of velocity. So that also you remember, its direction is always in the direction of velocity. SI unit of momentum is basically what? This much. Now dimension if you want to write, right? And momentum, if I talk now, when you understand, it is basically linear momentum. Okay. So this momentum means basically what I am talking about? I am talking about mostly linear momentum. You can tell also linear momentum, because we have one term also angular momentum, but here we are talking about only linear momentum. So momentum, linear momentum, you can write what the dimension of linear momentum, that is m to the power 1, l to the power 1, t to the power minus 1, t to the power minus 1, m1, l1, t to the power minus 1. Remember. So this is all our idea about momentum. And other relations what you know. Now momentum basically, momentum is nothing but mass into velocity you can write, mass into velocity you can write, or velocity is nothing but dx by dt. So where x is the displacement. So this is one formula you can keep. If x is given in terms of t, then you can find momentum also with this formula. Okay, where x is basically displacement. So v is nothing but dx by dt, and x is nothing but displacement. So momentum you can remember up to this also knowledge. It is a vector quantity. The SI unit of momentum is this much. Linear momentum formula, and another little extension of the formula, velocity is dx by dt. So that one alone you put here, m into dx by dt. It is coming like this. Okay. Try to understand this momentum. Now we'll understand change in momentum. Okay, what is change in momentum? We'll try to see the next. First to complete some basic idea about momentum. Next heading, right? Change in momentum. Change in momentum. Change in momentum symbol you give delta p vector. This is the symbol delta p vector. So what is this change in momentum? Now change in momentum I can write as final momentum minus initial momentum. So whenever I'll talk about change in momentum, that time what I'll write always? Final momentum minus initial momentum. Okay, so right here where PF is basically final momentum, and PI is nothing but initial momentum. Final momentum, initial momentum. So this delta P also I can write as final momentum, nothing but I'll write mass into V final, or mass initial V initial, also V final, like that I can write. Let me write mass is constant here. So here like this also I can write, or change in momentum I can take mass common, final velocity minus initial velocity. Like this also I can write. Okay, where VF is what? Now this is your mass into initial velocity and final velocity. So VF is nothing but final velocity, and VI is nothing but initial velocity. So this is the whole idea you are understanding about the change in momentum. Okay, so these 2 points you remember. When we want to find any case change in momentum, we'll talk about final momentum minus initial momentum, or especially we'll focus on mass times final velocity minus initial velocity. That idea should be here. Now some other points also remember. Already we have idea that AF equal to basically dp by dt here. So this dp by dt is nothing but dp is basically change in momentum, which is nothing but force into dt. So this expression you can remember, or magnitude wise if you want to write, change in momentum can be written as force into delta t. Okay, so this also I can write change in momentum. So remember, force into delta t, change in momentum I can write like this. Or from here also I can understand change in momentum I can get magnitude wise integration of f dt. Okay, change in momentum I can get from integration of f dt, or this one is called basically area under ft graph. From area under ft graph I can get also change in momentum. Change in momentum is final minus initial. Okay, f and t graph if is given, area under ft graph, or f versus t graph, f taken in y axis, t taken in x axis, ft graph will do, area under ft graph will give also change in momentum. That one also remember. Okay, and here one point you can remember. Suppose I have like this areas. Suppose this one is A1 area, it should be taken as a positive if you force time axis I am taking, and if I am telling this is A2 area, then A2 area will be taken as negative. So that means area above time axis is positive, and area below time axis what I'll take? Negative. Area below time axis I'll take as a negative, area above time axis I'll take positive. And this area under this graph, okay, will give me what? Change in momentum. That also you can understand here. So this many points you are remembering here. And a normal idea if you want to remember what is SI unit and all, star mark point you give. Okay, change in momentum, the SI unit of or change in momentum is a vector quantity, you can remember. Magnitude as also you can represent, this is the magnitude form. Okay, so delta P vector, magnitude if I will take now, this is delta P, which is magnitude of change in momentum. Magnitude of change in momentum, delta P. So remember, change in momentum is nothing but, change in momentum is a vector quantity. If a momentum vector, change in momentum also vector quantity. And what will be SI unit? Now the SI unit of change in momentum is a basic normal things. Remember, SI unit of change in momentum. So remember in physics, any quantity and its change will always have same unit, okay, or same dimension. Any quantity and its change in that quantity. So the length, change in length, volume, change in volume, okay. So momentum also, change in momentum will have same unit. The same unit of change in momentum is what? Kg meter second inverse. Now next point, write what is the dimension. Now for dimension of change in momentum I want to write, and this is m1 L1 t minus 1, because kg into meter into second inverse, or you can write also Newton into second, Newton into second. Change in momentum, that also you can write. Yes or no? So remember this formula. Newton into second also change in momentum unit. So this much idea we are getting. Now what we'll do, we'll take one situation, one problem we'll take, we'll try to understand how to find change in momentum in different exams. Your board exam also and competitive exam also, this change in momentum questions will be asked. So that is why this topic we have considered. So now listen here. Basic idea about change in momentum, remember, we'll try to find change in momentum for different situations. Area under force and time graph. Force in y-axis. F is taken in y-axis, T taken in x-axis. So area under FT graph is basically what? Gives you change in momentum. Area above time axis positive, area below time axis is negative. Clear? Remember that. So mass into velocity, that's why this unit is coming kg meter second inverse. Remember, mass na kg, velocity meter into second inverse. Newton second, why coming? Now because here change in momentum is force into time. So force into force unit is Newton, time unit is second. So change in momentum also Newton into second. So both the unit you can write. Okay. Later on another topic also will study based on this change in momentum, actually, that is impulse. Impulse is equal to change in momentum. Impulse unity is equal to change in momentum unit or momentum unit. Okay. Remember that. Now next listen. One illustration I am taking as a question number 1. What I am taking now, one wall is here. One wall is there. This is the wall. Now here one object, this is your horizontal, this is a vertical wall. Now here one object is coming. Object is coming with velocity. Suppose take v or u, whatever, u coming velocity. Mass is m. And it is making theta angle with the wall. Making in a direction it is coming, making theta angle with the wall. Again what is happening with the same angle? With the same angle this object is moving out. With same. Mass is m. This angle is theta. This angle theta, this angle also theta. Now listen. Here what they are asking? You find the change in momentum in this case. One object is coming with u velocity, hitting this wall and going with the same angle, making with the initial angle whatever made theta, same theta with the wall, and again it is going back. And when it is going with also same velocity u. Then you find what here? Find change in momentum. Question is find change in momentum in this case. Find change in momentum in this case. So this is your question. Try to understand everyone. One picture is given, they are asking you find change in momentum. So what you have to do? Now change in momentum formula already you know. So first what we will do, now we will try to calculate vector wise what is change in momentum. After that magnitude will check. Okay. So formula you apply, change in momentum formula. So write answers, right? Listen here. So first you check, you observe this situation, you observe. Whatever situation is given in the question, if you observe perfectly, you can find your initial velocity and final velocity, because when you want to find change in momentum, that time you need initial momentum, final momentum. Then you need to do what? Final momentum minus initial momentum you need to do. So now here you check, when this object is coming here, mass m, velocity is u, then what is its u, and it is making angle theta here, theta angle here. Now here, if I'll see here, this velocity u will have two components. One is in vertically downward, another is towards right. So if this angle is theta, this angle also theta, and this component will have u cos theta, and this component will have what? U sin theta. So velocity is having two components. Are you getting or not? Velocity is having two components. One in x-axis, another in y-axis. Similarly, if this is the initial case. This is the initial case. Let me write I here, initial. Now similarly, when it is coming out, here this ball is going like this with u velocity. Now this angle also theta given, this angle theta. Now here also two component I can make. One is vertical component, one is horizontal component of the velocity. One is horizontal component, one is the vertical component of velocity. Mass m is there. Now here this is the horizontal, this is the vertical. Okay, this horizontal, vertical, like that two component I can make. So now in dotted line, let me make here. Now this is one vertical and horizontal. If this angle is theta, remember this angle also will be theta. This angle is also theta. If this is u, this theta connected axis will give you u cos theta, and another component will give what? U sin theta. Are you getting or not? Here u cos theta, u sin theta. So now you got initial case, and this is I am giving as a final capital F. I am writing F. F means final case, initial case. Both the cases I am observing. Both the cases I am observing. Now all of you listen here. Now here if you want to write what is my initial momentum, what is initial momentum Pi, right here. What is initial momentum? Initial momentum will be Pi vector. So what is the Pi vector? Anyone can say? What is Pi vector? Now mass into velocity, initial velocity vector. Now mass into what is initial velocity vector? You check all of you. What is initial velocity vector? Now u vector is having two components. One is cos theta, another is what? Sin theta. Cos theta which direction? Negative y-axis. U sin theta which direction? Positive x-axis. So I can write here u sin theta I cap minus u cos theta j cap. Why I wrote minus? Because it is downward direction. Now next, if I write what is my final momentum, so I can write also what is my final momentum. That is Pf vector. That is nothing but mass into V final vector, or mass into, you check, tell me here, u has two component, u sin theta negative x-axis. This one is in negative y-axis. U cos theta negative y-axis. So now I can write here u cos theta, u sin theta in negative y, so minus u sin theta I cap, and again minus u cos theta j cap. So this is my initial momentum, final momentum. Now if I want to find change in momentum, so let me write change in momentum. What is change in momentum now? Now delta p vector, which is final momentum minus initial momentum. Final momentum minus initial momentum. Are you getting or not? Check everyone clearly. Initial final case if you understood now, then change in momentum finding not a difficult job. Initially velocity in this direction, that's why it is a vertical component u cos theta minus j cap, and another is u sin theta plus I cap, because this theta will be equal, because these two lines now, if this is intersecting, then this angle and this angle will be equal. So remember that. So that is the reason it is happening. And here these two angles are equal, theta theta. Okay, geometry, basic geometry. Now here if you want to m into minus u sin theta I cap, then minus u cos theta j cap. then minus initial momentum. What is that? Mu sin theta I cap minus u cos theta j cap. So this one you need to do. So now listen here. Now change in momentum is nothing but multiply now minus mu sin theta I cap, then minus mu cos theta j cap, then minus mu sin theta I cap, minus minus plus mu cos theta j cap. Now see what will happen here. Something is getting cancelled here, right? Which one is getting cancelled? Check. Mu minus mu cos theta j cap plus mu cos theta j cap cancelling. Now change in momentum is coming what? Minus 2 mu sin theta I cap. This one remember. So actually change in momentum direction is coming which direction? Negative negative x-axis. So minus mu sin theta j cap. This is the vector wise coming. Now if I want to find magnitude wise, then this is delta p. So this is nothing but only 2 mu cos sin theta. 2 mu sin theta. So this is the magnitude. This is the magnitude of change in momentum. Magnitude of change in momentum. Okay. So this is vector wise, this is magnitude wise. Delta p vector mod is 2 mu sin theta. It is coming here. Okay. So this much you should understand. For this question they ask for change in momentum, either vector wise or magnitude wise you take. Vector wise or magnitude wise you take. Yes. Yes or no? So you got change in momentum. Now next listen. Sometimes some other question also they can ask for this particular thing. They can tell suppose time taken is t. Time taken is t. Then what will be the average force on that wall? What will be the average force on the wall? That one also try to see. Okay. So change in momentum you got. Magnitude of change in momentum. Yes or no? Now listen here. Suppose in this case, sometimes they can ask what is the average force? What is the average force on wall? What is the average force on wall? Now that will be your change in momentum by time. This time will be given. So what is the change in momentum here? 2 mu sin theta by t. 2 mu sin theta by t. That is your average force. Change in momentum you got, right? That change in momentum by time you do now, you get the average force. Okay. So first you note it down about change in momentum. Once you got initial final, then change in momentum is final minus initial. Remember this is your final and this is your initial. So final minus initial if you do, okay, what will get? You will get about change in momentum. Clear idea? And change in momentum direction is negative x-axis. Negative x-axis. And magnitude you find, after magnitude if they ask, you find any force, average force on wall, you can do this, average force on wall. Clear? No doubt? Note it down. So now, you got average force also, change in momentum by time, average force. Now another question you take. Suppose one object is coming normally and hitting this. Object is coming perpendicular to this wall with u velocity and it is moving away also, it is going away also with same u velocity, mass m. This is your wall. After hitting wall, it is going with u velocity, same u velocity. but here this time perpendicularly it is colliding with the wall. Now here also suppose they ask what is the find change in momentum. Find change in momentum. Here also you can find change in momentum. For this question I am telling. Okay. What is the change in momentum? Can you find or not? What is the change in momentum formula? Final momentum minus initial momentum. So answer right. Right answer here for this question. Here first find what is initial momentum. Initial momentum everyone check. Mass and u. See mass is there, u is velocity. It is going towards right. So mass into u I cap. And final velocity is what? Minus m into u I cap. Final momentum. Mass into u is velocity going towards left. Now what is the change in momentum? Change in momentum. Change in momentum is delta p vector, which is final momentum minus initial momentum. Now what is the final momentum? This one is final momentum. What is that? Minus mu I cap. Minus of mu I cap. Now what will happen? You say here minus 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 mu I cap minus mu I cap. So I write it is minus 2 mu I cap. This is your change in momentum. Minus 2 mu I cap. Or you can write change in momentum magnitude equal to delta p, which is 2 mu. This is the magnitude here. This is the magnitude. Now next if you want to find average force. If you want to find average force also you can find here. What is average force? Now average force equal to change in momentum by time or 2 mu by t. 2 mu by t. Okay. So you try to understand here. Momentum in initial, final. Then change in momentum is final minus initial. This is the final you take here. Initial you take here. Then change in momentum is minus mu I cap minus mu I cap. It is coming minus 2 mu I cap. Okay. So this is the way you have to find a change in momentum. Previous case, that object was making certain angle theta. But in this case what is happening? Now direct hitting happening. Okay, normally. Ball is hitting normally here. This is the ball. Okay. So ball is hitting normally to wall. Ball is colliding normally to the wall. Ball is colliding normally. Are you able to understand? No worries. Change in momentum is what? Final momentum minus initial momentum. This is what you have to understand here. That's all. I hope you understood, right? Yes or no? Okay. Like and subscribe Vidya Lakshmi NEET Academy YouTube channel. All the very best.